Welcome to another episode of Catch This. My name is Trudy Ray. Have you ever wondered if you can mix and match SARS-CoV-2 vaccines? For example, would it be okay to boost a first dose of the vaccine produced by AstraZeneca with a dose of the vaccine produced by Pfizer BioNTech? The latest science shows that such a vaccine regimen actually induces a stronger immune response than a regimen consisting of 2 doses of the same vaccine. I will discuss some of these new data in this video. Stay tuned. As you may remember, the occasional incidence of thrombosis in people under the age of 60 after receiving an adenovirus vectored vaccine like the ones made by AstraZeneca and Johnson & Johnson has prompted several European governments to only recommend the use of these vaccines in people over 60. However, by the time this recommendation was made, many people under 60 had already been vaccinated with the first dose of the AstraZeneca vaccine, and they still needed a second dose. This left them with a decision of either continuing their regimen with another dose of the same vaccine, that is a homologous regimen, or receiving an mRNA vaccine instead, and that would be a heterologous regimen. In an effort to evaluate the efficacy of a heterologous SARS-CoV-2 vaccine regimen, the authors of this brief communication right here engaged the participants of an ongoing clinical trial which aims to monitor the immune responses to SARS-CoV-2 in healthcare professionals and individuals with potential exposure to SARS-CoV-2. All study participants had already received a first dose of the AstraZeneca vaccine, referred to as ChAd in the study, and were given the option of receiving a second dose of the same vaccine or a dose of Pfizer BioNTech's mRNA vaccine, referred to as BNT. Now, both of these vaccines encode the gene for the full-length SARS-CoV-2 spike protein, but it is housed slightly differently. In the ChAd vaccine, which was discussed on Catch This episode 4, linked above, the spike protein is encoded in an adenovirus vector of chimpanzee origin, while in the BNT vaccine, discussed on Catch This episode 3, also linked above, it is surrounded by a lipid nanoparticle. Out of the 87 individuals who participated in the study, 32 chose a second dose of ChAd, and 55 chose to be vaccinated with BNT instead. Participants who chose a homologous ChAd regimen received their second dose of ChAd on day 73 after the initial dose and donated a blood sample for analysis 16 days later. Participants who chose a heterologous ChAd-BNT regimen received their dose of BNT 74 days after their initial ChAd dose and donated a blood sample 17 days later. All results obtained from the analyses of the blood samples from these two groups were compared to results obtained from a group of 46 healthcare professionals who had been vaccinated with 2 doses of BNT, that is a homologous BNT-BNT regimen. So what did they find? Relative to the antibody levels induced by the first dose, homologous boosting with ChAd led to a 2.9-fold increase in IgG antibodies against the SARS-CoV-2 spike protein. Just as a reminder, IgG antibodies are mostly present in the blood and provide the majority of antibody-based immunity against invading pathogens. In contrast, heterologous boosting with BNT led to an 11.5-fold increase in anti-spike IgG, within the range observed in BNT vaccinated individuals. A similar pattern was observed with anti-spike IgA antibodies, which are predominantly found in mucous membranes and their fluids. Boosting with BNT induced significantly higher increases in anti-spike IgA than did boosting with ChAd, suggesting that a heterologous boosting regimen induces better antibody responses. Interestingly, although the booster immunization induced an increase in neutralizing, which are virus inactivating antibodies in both vaccination groups, only heterologous ChAd-BNT vaccination induced antibodies that neutralized all 3 tested variants, alpha, beta, and gamma. similarly to what was observed in BNT vaccine recipients. The authors also analyzed the effect of the two different boosting regimens on spike-specific memory B cells, which circulate quiescently in the bloodstream and can quickly produce spike-specific antibodies upon a subsequent exposure to SARS-CoV-2. All vaccinees from both the ChAd-ChAd and ChAd-BNT groups produced increased levels of spike-specific memory B cells after receiving their booster shot, with no significant differences observed between the two groups. These results emphasize the importance of booster vaccination for full protection from SARS-CoV-2 infection. ChAd-BNT recipients also had significantly higher levels of spike-specific CD4 and CD8 positive T cells compared to ChAd-ChAd recipients. CD4 positive T cells are a central element of the adaptive immune response because they activate both antibody-secreting B cells and CD8 positive T cells that kill infected target cells. Compared to the ChAd-ChAd regimen, ChAd-BNT vaccination also induced significantly increased levels of T cells that produce spike-specific interferon gamma, a cytokine that inhibits viral replication and activates macrophages, which are phagocytic cells that engulf and digest pathogens. Overall, these results suggest that a heterologous ChAd-BNT regimen induces significantly stronger immune responses than a homologous ChAd-ChAd regimen. The study did have several limitations. First, it was not a randomized placebo-controlled trial where each participant is randomly assigned to an experimental group or a control group. Randomizing trial participants eliminates unwanted effects that have nothing to do with the variables being analyzed, so that the only expected differences between the experimental and control groups are the outcome variable studied, which was efficacy in this case. Subjects in a control group receive a placebo, a substance that has no therapeutic effect, so that one can be sure that the effects observed in the experimental group are real and result from the experimental drug or vaccine. Second, the authors were unable to test the antibodies for their ability to neutralize the Delta variant, which has recently become the predominantly circulating variant in many parts of the world. Third, the study mostly included young and healthy people, making it difficult to generalize the data to other specific patient groups outside of this category. Fourth, the data only show the results of assays performed in vitro, which may not necessarily reflect a clinical significance. Extended studies aimed at determining the practical importance of the observed immune responses are needed to validate the relevance of these responses. Despite its limitations, the study provides information that could have some valuable practical implications. Most of the currently approved SARS-CoV-2 vaccine regimens involve 2 doses of the same vaccine. However, you may not always have access to 2 doses of the same vaccine under some circumstances. One specific scenario I can think of is if you receive your first dose in one country and then for some reason have to travel to another country where that exact same vaccine may not be available. In that case, you would need to boost your first dose with a vaccine of a different kind. And it turns out that that is just fine, which really makes a lot of sense when you consider that all of the most commonly used vaccines contain the same antigen, the SARS-CoV-2 spike protein. That's it for today. Thanks again for listening. My name is Trudy Ray. Please subscribe. I'll see you next time on Catch This.